Next example comes out of 5.1, graphing sine and cosine functions. In this example, we're asked to draw three graphs, y equals cos x, y equals cos of 3x, y equals cos of a half x. Hopefully, again, you recognize that this should be a transformation, and even a transformation you've seen before. When you take x in any equation that you're graphing and you multiply it by something, you expect you're going to do horizontal stretches. So you'd be right if you said this first one was going to be a horizontal stretch by a factor of a third, and the second one was going to be a horizontal stretch by a factor of 2 compared to the original y equals cos x. So I've put some axes down here so we can do each of these separately. Y equals cos x, hopefully you're getting pretty good at drawing. It goes through the point 0, 1. It has a period of 2 pi, so it'll be back at that point. Halfway in between it'll be at its minimum. Halfway between it'll have x-intercepts, and you'll connect the dots, something like that. And you can do the same thing in the negative direction if they asked you for 2 cycles of the graph. Y equals cos x looks something like that. Now, to horizontally stretch that by a factor of a third can be a little tricky. This is, for a lot of people, the hardest of the transformations in these trig functions. First thing I would recommend is remind yourself what the period is. The period of the untransformed cosine graph is 2 pi. The period of y equals cos of 3x, if you horizontally are stretching by a factor of a third, your period is a third as big. So you're going to have a third times 2 pi, which is 2 pi over 3. So it's worth numbering my axes slightly more accurately so that maybe I have a third of a pi every tick on here, because really what's going to happen is the point that's at 0, 1 will still be at 0, 1, but my period now is only 2 pi over 3. This graph is going to do a full cycle by the time you get here to 2 pi over 3. Halfway in between, it'll be at its minimum, and then in between those, it'll have intercepts. So one cycle of this graph is going to be pretty tight, pretty short. So 0, 1 is worth labeling, but so is 2 pi over 3 comma 1, because it shows that you know how long the cycle is or how long the period is. You may also label this one at the bottom here, pi over 3 comma negative 1, showing that you know how low this graph goes. Once you have one cycle drawn accurately, the others you can sketch in a little bit more haphazard, and you probably wouldn't lose big time marks for them. But basically what you should discover is that by the time you get to 2 pi, where you would have normally had one full cycle of a cos graph, you now have 3, which makes sense since it's a third as wide as it used to be. And if you went in the negative direction, the same thing would happen. You'd have 1, 2, 3 kind of full cycles, and not very well drawn, but you get the idea, I hope. Now the last one we're doing is y equals cos of a half x. We said it's the horizontal stretch by a factor of 2, so the period is not going to be 2 pi anymore. It's going to be 2 times 2 pi, which is actually 4 pi. So you may actually probably, if you're doing this question on a test, get a larger set of axes to draw it, because it's still going to go through 0, 1, but it won't even get through a full cycle by the time it gets to 2 pi. It'll only be halfway through a cycle. And so it'll look something roughly like that as you go to the right, and like that as you go to the left. Now what you see here now is one full cycle going from negative 2 pi to positive 2 pi. If I label the point, 0, 1 is always a good one, 2 pi comma negative 1, or negative 2 pi comma negative 1 are good ones as well. If you went further to the right, you go all the way to 4 pi before you'd get back up to positive 1, and you could see a full cycle to the right. So there are some some cosine functions that have been horizontally stretched. You would find, while I mentioned sine, that the same thing would happen to a sine function. If you horizontally stretch a sine function, you change its period from 2 pi to something else, and you just draw your cycle accordingly. Just as in the previous example, we did vertical stretches, and vertical stretches will affect sine graphs just as they will cosine graphs in the same way.